Okay, students, we're going to go ahead and get started. What we want to do is go into Google. I'll put this over here out of the way. Alright, so we're going to go into Google and we're logged in through App Creators. We logged into Project Lead the Way, so we're in Activity 2.1. So we're going to read through this. Our activity is Keep Me in the Loop. Our goals are to plan, analyze, and create algorithms that include loops, trace the value of a variable for each iteration of the loop, identify how abstraction hides the complexity of a task. Our resources are the Keep Me in the Loop file. Okay, so imagine baking cupcakes for everyone in your school. What if the recipe called for 200 eggs and listed crack an egg and add to the batter 200 times? Not only would it be a long recipe, but you might lose count and would have to start over. In computer science, programs may have thousands of lines of the same repetitive code. Computer scientists use many strategies to reduce the amount of redundancy, to shorten the code and make it easier to read and understand. In this activity, you will explore one of those strategies. Redundancy is duplicated or repeated code within a program. Alright, so algorithms with repetition. In the Amazing Algorithms activity, you wrote an algorithm to direct a school bus to travel from the school to a museum. So remember, we went through here down to get to the museum, or we could have went up here. Let's examine the portion of the possible algorithm for the bus's journey to identify the repetitive steps for the flow chart. The flow chart for the first part of the algorithm is shown below. Begin, move forward, move forward, move forward, move forward, turn left. End. Move forward, move forward, move forward, move forward, turn left. Which steps are repeated in the continuous sequence? Begin, move forward 4 times. This was the only one that's different. What do you think can be done to the algorithm to reduce redundancy? The four move forward blocks can be condensed into one block that moves forward 4 times. Computer scientists use loops whenever they want their programs to repeat steps within an algorithm. In an algorithm, whenever you want to repeat steps a specific number of times, you use a specific type of loop called a for loop. To execute a for loop, a program will use conditional statements using yes, no, true, false questions. Backing up for a moment, a for loop is a type of loop that repeats for a given number of times, and conditional statements is a command that performs different actions depending on whether a condition is true or false. If the condition is yes, true, it continues to the next set of blocks. If the condition is no, false, it goes back and repeats the previous step again. Which decision block in a flowchart is used to respond yes or no to or true false statements? Alright, that would be a rhombus. Show answer. That's right. Alright, using what you have learned about conditional algorithms, how could you rewrite the flowchart using conditional statements to build a for loop? So here is our example. Move forward, move forward, move forward, move forward, turn left. So remember, we did something like this earlier. We said, can you move forward? Yes. Can you move forward? Yes. Can you move forward? Yes. Can you move forward? No. Can you turn left? Yes. That's kind of a conditional statement. If we press this right here, we can see begin, move forward, increment by one number, move forward. Is the number greater than endpoint? If it's yes, then turn left. If it's not, then we go back to move forward. So we could come in here, move forward, move forward. Can you go forward anymore? Yes. Turn left. If not, can you not go forward anymore? Yes, turn left. If you can, then you go back to move forward. So it recircles itself. reflect on learning by looking at this chart. Create the necessary for loops to reduce any repeated steps in the following chart. So we're going to move forward, turn left, turn left, turn left, move forward, move forward, move forward, turn left. So we can put these turn lefts together, we could put these move forwards together, and then we can leave that one alone. Alright, so flow chart for the bus to drive to the museum. So we could combine these three. Alright, this will be by itself, these three will be together, these will be together, this will be by itself. You can create for loops in App Inventor using the for each control block located in the control drawer, which is right here. Let's explore this block using the example algorithm for the bus route. Let's assume that we want the bus to move forward 4 times in a row. The for number from the for each number from block 2 represents a loop that represents the code inside a specific number of times. So from 1 to 5 and increase by 5. Alright. Let's explore the block using the algorithm for the bus route. Let's assume that we want to move the bus to move forward 4 times in a row. For each number from the from to block represents a loop that represents code inside of each specific number of times. The number of times it repeats is based on the values identified in the from, to, and by parameters. Parameters are a value provided as an input to a code block or predefined procedure. Okay? The variable named header, the variable named in its header, which is the first line in a code block that embodies other blocks. The top line of the text for an event handler or an if-else block or a for loop. The variable name header, called by the number by default, is initialized to the starting point specified in the from parameter, and then in this example the number is initialized to 1 rather. So we can see here starting from 1 going to 5, increment by 1. So 1, 2, 3, 4, end at 5. Alright, the by parameter is called the increment, which specifies the value that will be added to each local variable number after every iteration. Local simply means the variable that is only accessible inside that block of code. And iteration is the execution of one pass of a loop. Okay. The loop stops after a number exceeds the endpoint specified in the parameter. In this example, the endpoint is 4, so the loop will run the number equals 4 or 4 times. When the number becomes 5, the loop will stop because the number is now out of range and specified in the loop header. So this means in the code below, the bus moves forward 4 times, once for a number equaling 1, then for a number equal 2, then for a number equal 3, and finally for a number equal 4. So it starts at 1, ends at 4, and increments 4 by 1. And see, we just called a block called move forward. What if by the by increment is set to 3 in the block above? How many times will the loop repeat? What will the value be after each iteration? Well, it's only going to go 1 time because it's only going to be able to move 1 time inside of 4. Fill out the variable trace chart to keep track of the loop iteration and the variable number after each. Okay, students, so if we take a look at this, it said what if the by increment was set to 3 in the block above? How many times will the loop repeat? The loop will then run only twice. The first iteration is the number. Second iteration will be 1 plus 3 equals 4. It will stop after that because the number becomes 7, which is out of range. Alright, so fill out the variable tracing chart to track the loop iteration number and the variable for each number for each iteration. So the first one would be 1, and it would start out at 1. The second would be 4, because it would be 1 plus 3 equals 4. And the third iteration would be 3 plus, or 4 plus 3 would equal 7. Alright, so that's how it would lay out. Okay, so looking at this under C, it said what should the from, to, and by parameters be if you want to display the name of every other student in a class of 15. You'd start with 1, then you would do 15, okay, and you would increment by 2, okay. Alright, how could we represent the App Inventor block with the flowchart? The flowchart is conditional because the loop has to check the value of the variable number and ensure that it is within the range in the loop specified in the loop header. So here we go. We could take a look at this. We could see that begin set number to 1. Is the number greater at the end point? Alright, if it is, yes, we're going to turn left. If it's not, we'll go forward and move forward. Then we'll increment by 1, and we'll keep doing that till we get to where we can turn left. Then we'll turn left and go to end. So here is a visualization of what that would look like. Okay? Alright, so now we're going to get into building an app, and that will be in the next video.